Hello everybody, we continue talking about different element types and accuracy, and in this video we will talk about the non-linear or 20 nodes hexa elements and why it's not present in previous video. The link would be here. So firstly let's talk about general hexa with 8 nodes. If we check our mesh, we can see that it's 8 node hexa element. So we have a result of deformation and it's the same. As you see, it's very normal. Also we can see equivalent stress and it's also normal. Yep, it's not present here the mid plane with zero stress, but we talked on a previous video that it's okay. So we say that it's present linear distribution of a tensile and compression stress along height of our beam, and we see that we have linear stress distribution along wall element for linear hexa. So it's almost okay, but the problem is absent of zero stress in one Mises picture. So also we have a model analysis, and we can see that our frequency starts from 800, and the first couple of form and modes look like this one. It's simple bending, so it's normal. And now we check another question. So we came here and we change the linear element to quadratic. We create new mesh. We check this mesh. Sometimes it don't want to work. Okay, let's show by hand. So as you see, both object has 20 nodes hexa. They have mid-side node on element. Okay. And now let's try to solve it. And if we solve, we'll obtain an error. It's no any kind of result. Now we can open solution information. We can see that we have displacement in the end of nowhere for some nodes. We can see here this kind of problem also. Just a moment. Here it is. So there are some problems. We simply change the type of element from the linear hexa to beta 1 to quadratic hexa with mid-sides, and we obtain some strange error. Okay, let's take a look to the model analysis. We will not obtain error, we obtain result, but this result will have some strange. So if we take a look into result, firstly it looked like normal, but then if we take a look here, we will see that our first 10 results are 0. If we compare to the normal one to 800, 1.2 e minus 2, it's almost 0. So if we take a look into our modes, we can see very strange and very interesting situations that our mid-side nodes and original nodes in corner try to deform in a very different way, very different direction. And only 11 form for this one will be the form with 800 Hz, and it's for this beam, for this object with solid 20 hexa element, and it's normal. And we have problem only on this beam with 1 elements per thickness and per width. We doesn't have this problem here when we have couple of elements. So let's do something like this. We check this object and suppress it. And let's try to calculate static structural task. And as you see, we obtain result, we obtain deformation, we obtain stress, and you can see the natural plane here. So it's good. We can see the stress distribution, averaged, unaveraged, and in everywhere we see those kind of picture. Okay, let's invert our suppression. So now we have this body. Let's try to calculate, and we see this type of error. So in some cases, Ansys, and it's not only Ansys mechanical Ansys workbench, it also can be found in Ansys EPDL in classical Ansys. In some cases, without any additional options, solid 20 nodes hexa element give an error when we have only 1 element per side, per thickness and per width. It doesn't appear when we have couple of elements per thickness or per width, but it can appear in some cases. Yeah, I know that this object better to solve in beam approach and so on, but it's not about beam, it's about solid object. And maybe if we take a look into help and set some additional options, we will doesn't have this problem. I was very shocked and surprised when see this problem, because I don't think that it will appear. And additionally, I check this case with other software. It's Siemens NX Advanced Simulation, Siemens NX Kaya. It uses NX Nastran to obtain result. And we have 2 different objects. One of them use C-Hexa 8 node. The second use C-Hexa 20 node, so it's with parabolic object. And if we take a look to result, we can see that we have just a moment, where it is. We can see that we have a result for both object in displacement and in stress. And in stress. And we can see here the same situation, that we have linear distribution through element, but without the natural plane with 1 meter stress here. And we can see the natural plane with 0 stress here. So it's not an option of 20 nodes Hexa element. It's an option of current maybe element in Ansys, or maybe of Ansys solver. Really, it was very surprising for me, so for now I can't answer why it's so. But it's the reason why I don't show result for nonlinear quadratic Hexa with mid-sides on the previous video. And this problem sometimes appear not only with one-to-one elements, sometimes it appear on more complex construction with bigger number of elements. I really don't understand it. I only do some short investigation and doesn't have good description and good explanation for this situation. If you know something about this case, please write a comment. It will be very interesting. Bye.